What is time complexity of a program and why is it important? We'll try to see through an example. Ram and Shyam are two students and they have both been given the same assignment. And the assignment is that given a number n, they have to find out whether n is prime or not. A prime number is a number that can be divided by exactly two numbers, 1 and the number itself. The smallest prime number is 2 and some of the other prime numbers are 3, 5, 7, 11 and we can go on. 1 is not a prime number because 1 can be divided by exactly one number and that's 1 only. So a prime number should have exactly two factors. Both Ram and Shyam figure out different solutions to the problem. Ram says that, hey, I'll try dividing n by all numbers starting 2 all the way till n minus 1, and if I can find any such number that divides n, so if I can find any I between 2 to n minus 1 that divides n, then n is not prime. Shyam, however, is intelligent enough to realize that he does not need to check all the way till n minus 1. Only if he cannot find an I till square root of n, he can be sure about whether the number is prime or not. So he says that for I starting 2 to square root of n, if there is any such I that divides n, then n is not prime. Both of these solutions are correct, and let's say for now that Ram and Shyam have handled the special case for 1 separately. Both of these will work, and we will not go into the details of why they will work. Let's just assume for now that they will work fine. Now when they both run their program, for larger input sizes, Ram is quite sad, while Shyam has a big smile on his face. And why is it so? Let's try to see. Let's say Mr. Computer, who has to run this program, takes 1 millisecond for a division operation. So we'll say 1 millisecond for division. Let's see what happens for various inputs of n. In the worst case, Ram's loop will run exactly n minus 2 times, so it will perform exactly n minus 2 divisions, and that would happen when the number is prime. However, for Shyam, in the worst case, he will perform exactly square root of n minus 1 times the division. Let's pick up various values of n and see what is the time taken by these programs. We'll pick up a small n first. N is equal to 11 and 11 is a prime number, so the loop will run from the loop will run starting 2 all the way till 10, so this will take exactly 11 minus 2 milliseconds, which is 9 milliseconds. Shyam, however, will take square root of n, or square root of 11 is 3 point something. We are only interested in the integer values, so the loop will run only for 2 and 3. So the loop will run exactly 3 minus 1 times, and the time taken will be 2 milliseconds. 9 milliseconds and 2 milliseconds, not much of a difference in terms of computational time. Let's pick up a higher value. For n is equal to 101, and that is a prime as well. Ram will take 99 milliseconds. Shyam, however, will take square root of 101 is 10 point something, so Shyam will take 10 minus 1 or 9 milliseconds. This is still less than 1 second, and Mr. Computer won't give you much of a hint of the actual runtime for such small value or duration. Let's pick up a slightly higher number this time, and we'll pick up a 7-digit prime number this time. This is, now this is equal to 10 to the power 6 plus 3. We'll say this is also equal to 10 to the power 6 plus 3. So Ram will take almost close to 10 to the power 6 milliseconds to solve this problem. And if you convert this to seconds, this is 10 to the power 3 seconds, or 16.66 minutes. And let's see how Mr. Shyam does here. Shyam will take square root of 10 to the power 6 plus 3 minus 1, and for larger values of n we can safely ignore these minus 1 here, and this is almost close to 10 to the power 3 milliseconds, which is only 1 second. So now we can see a visible difference here. While Ram is taking 16.66 minutes for this input, Shyam is able to solve this problem only in 1 second. Let's pick up a really higher value this time, an 11-digit prime number, and the number is which is also equal to 10 to the power 10 plus 19, and this is a prime as well. So the loop will run exactly n minus 2 times. So Ram's program will take close to 10 to the power 10 milliseconds, which is equal to 10 to the power 7 seconds. If you try to convert this to minutes, hours, and then days, this will be a little more than 115 days, which is quite an impractical time for a program to solve a problem. And let us see how Shyam's program does here. Shyam will take close to square root of 10 to the power 10 is almost equal to 10 to the power 5. So Shyam will take around 10 to the power 5 milliseconds, which is only 100 seconds, or 1.66 minutes. Now we can see why Shyam is quite happy and Ram is sad. While Shyam is solving the problem in 1.66 minutes here, Ram is taking an impractical time of 115 days for this input size. Time complexity of a program is the simple measurement of how fast the time taken by the program grows if the input size increases. So if the input to the program is n, we can see that in the first case, the time taken by the program is proportional to n. We often say in computational terms that this program is an order of n algorithm. This O is called big O, and you can search over the internet for what it is. We will not go into the detailed mathematical assumptions behind this notation for now. Shyam's program, as you can see, is proportional. The time taken by Shyam's program is proportional to square root of n, and we say that this is an order of square root of n algorithm, and we represent it by big O square root of n. So we realize through this example that correctness of the program is not the only thing. What's also important is how your program behaves for larger input sizes, and we should always try to write a program that behaves well for larger input sizes. So thanks for watching.